As you can see, logarithm and logarithmic functions. So this is what we have today. The first subtopic is define and evaluate logarithms. The second is use inverse properties of logarithmic and exponential functions. We're asked to use inverse properties of logarithmic and exponential function, and finally graph logarithmic functions. So let's go on to define and evaluate logarithm with base b. So definition of logarithm with what? Base e. Definition of logarithm with base e. So this is the first definition of logarithm with base b. Let b and y be positive real numbers with b not equal to 0. Let b and y be positive real numbers, b and y be positive real numbers with b not equal to 1. The logarithm of y with base b is denoted by, then if this is the same, then we have log b to base y. This is the logarithm of y to base b. This is sorry, if y and b and y be positive real numbers with b not equal to 0, the logarithm of y with b is denoted as log y to base b, and sometimes can be called log to base b of y. So this can be defined if x is equals to log y to base b, if and only if b raised to power x is equals to y. So if x is equals to log y to base b, if and only if b raised to power s is equals to y. This is the same as finding the logarithm of both sides. How can this be proved? How can we find this logarithm for the exponential function? Yes, we can do that by taking logarithm to base b of both sides. I hope you are seeing it. For example, you are given b raised to power x is equals to y. Take logarithm to base b of each side. You have that log to base b raised to power x is equals to what? Log to base b of y. So we know that from logarithm, log b to base b is equals to 1. Any log to its base is equals to 1. So from here we have what? S log b to base b is equals to what? Log y to base b. So from here, since log b to base b is equals to 1, if we put it here, it will be s times 1. This gives us s is equals to what? Log y to base b. So this means this is correct. X is equals to log y to base b if and only if b raised to power s is equals to y. So from there we prove it by taking logarithm to base b of each side, and then simplify using the laws of logarithm to arrive that x is equals to log y to base b. This is in logarithm form. This is in logarithmic form. I hope you are seeing it. This is in logarithm form, and this is what in exponent form, exponential form. So let's proceed. We can now clean the board and proceed. So two special logarithm values we have. Before we go into some problems involving logarithmic equation and function, you still have to refer to knowledge you have in laws of logarithm or properties of logarithm function for you to be able to follow up if you haven't done that in the past. There are two special logarithm values we have. Two special logarithm values we have. Let b be a positive real number such that b is not equal to 1. Let b be a, I hope you are following, I'm making sense, I'm making some theory part of it. Let b be a positive real number such that b is not equal to 1. If b is not equal to 1, we now define logarithm of 1. This is 1, logarithm of 1. Let b be a positive real number such that b is not equal to 1, which means log 1 to base b is equals to 0, because in exponential form 1 is equals to b raised to power 0, and any number to the power of 0 is equals to 1. Then again, logarithm of base, logarithm of b with base b with base so logarithm of b with base b. So from here we have log b to base b is equals to 1, because b is equals to, write it in exponential form, b is equals to b raised to power 1, and any number to the power of 1 or exponent 1 is the same number. 2 to the exponent of 1 is equals to 2. 3 to the exponent of 1 is equals to 3. So these are two special logarithm values you have to understand. So, but there's another one I put for you, log. For example, you have log. In this case, we have a to the power of c base b. This is the same as c log a to base b. So because this is the same as this is different from this these two special logarithm. This one is different. So log a to exponent c in base b is equals to c log a to base b. Because, for example, this is a special, you have to know this. So let's proceed. I added it so that it will be easy for you. So let's proceed. Writing logarithmic equations. Writing logarithmic equation. So exponential form. Writing logarithmic equation into logarithmic equation to exponential in exponential form. So you are asked to write a given logarithmic equation in exponential form. So you have log 16 is equals to minus 4. So you're asked to write it in this form: y equals to b raised to power x. So how do you do that? Write it in this form, because the logarithm of this form, its logarithm is equals to x equals to what? Log y to base b. So you're asked to write this in this form. To do that, we now have to simplify, that is multiply the base to this and rise the base to the exponent of minus 4. So this implies 16 is equals to 1 over 2 to the exponent of minus 4. So this is the first step you have to follow. The next is to simplify this. This is the same as 2 raised to the power minus 1. You know that indices 2 raised to the exponent of minus 1 will give us half. So rewrite it in this form. If you open bracket, you have 2 minus 1 times minus 4. Is it not? So this will give us 2 to the exponent of 4. So this is what you are required to do. So 16 is equal to what? 2 to the exponent of 4. That is what you are required to do. So the second one, we are given log to base 7 343 is equals to 3. So you are required to do what? Write it in exponential form. We know that looking at this 343, 3 is a factor of 343, because we know that 343 is equals to what? 3 raised to the power 7. If you expand this, you have this. So this is equals to, so you have to apply this rule. Just this is equals to 343 equal to 7 to the exponent of 3. Rise the base to the exponent of 3 as of this. That is all. Always rise whatever that is here. Rise the base to the exponent of whatever that is here. Or you simplify this, but there is no, just to rise it to the power of this in this form. In this case, this is in exponential form. This is called exponential form. Alright, do this one. Do this. Log 1 over 3 to base 3 is equals to minus 1. The second is 2. The second is log 32 to base half equals to minus 5. So do these two. Do them and bring them to me. Writing the equation in logarithmic form. We have done exponential form. The next is in logarithmic form. Writing the equation in logarithmic form. This is logarithmic form. So I can clean here. Have any question? Alright, first one is 5 raised to power minus 2 is equals to 1 over 25. So you're asked to write it in logarithm form. We are now given y equals to p raised to power s. In logarithm form, you have x equals to what? Log y to base b. So you are given in this form. You are asked to put it in this form. We are given the form in exponential. We are asked to put it in logarithm form. The first thing is to take logarithm of both sides. Take log to base 5 of each side. So this will give us what? Log to base 5. 5 raised to power minus 2 is the same thing as log 1 over 25 to base 5. So this is the first thing. From here we know that this coming to this side will give us minus 2 is equals minus 2 log 5 to base 5. This will give us log to base 5 1 over 25. So that is it, because we know that log b to base b is equals to 1. So this is equals to minus 2 times 1. This will give us minus 2 is equals to log 1 over 25 to base 5. So this is what we are required to do. Write equation in logarithmic form from exponential to logarithm. So this is what you will have. Always take the logarithm of both sides based on the value of b. The value of b will give you the base logarithm you are to be used. If this is 6, here will be 6. 7, here will be 7. So let's continue. Not exactly the base. It depends on the factors of the base. Let's do more example for clarification. So see example 2. 125 to the power of 1 over 2 over 3 is equals to 25. So looking at this, you see that you can simplify this. If you look at the two, you only see the difference between the two. The first is to consider you have to know that bet 125 is the same as 25 is the same thing as 5 raised to the power 3. This is the same thing as what? 5 raised to the power 3. So we now go into solving it. So from here, we now substitute in this value. Whenever it's 125, we put 5 raised to the power 3. This will give us 5 raised to the power 3 in bracket 2 over 3 is equals to 25. So this is the first thing. You can now, if you open bracket 3 will cancel out to give us 5 raised to the power 2 is equals to 25. So in this case, you can now take log to base 5 of what each side. If you take log to base 5 of each side, we have what? 2 to base 5 raised to the power 2 is equals to what? Log 25 to base 5. So that from here we already know that log b to base b is equals to 1. So from here I have 2 log 5 to base 5 is equals to what? Log 25 to base 5. So this is 1. 2 times 1 is 2. So 2 is equals to what? Log 25 to base 5. So this is how you can write it in logarithm form. Have any question? Alright, do this one. The first one is 49 to the power of half is equals to 7. The second one is 256 to the power of 1 over 8 is equals to 2. You're asked to write them in logarithm form. So let's continue. Let's do some evaluation of the logarithm. Have any question? Evaluate the logarithm. So the next is to evaluation of logarithms. Evaluation of logarithm. If you have learned indices in your your junior class, and also if you have learned more about a logarithm, you can follow up in this lesson. You have to refer to the properties and the laws of logarithm. So the first is you are given log 1 over 625 to base 5. So how do you evaluate this logarithm? The first thing is to recognize the value of 625. We know that 625 is the same thing as 25 squared, and 25 squared is equals to what? 5 5 square times 2, because of these 2, to give us 5 raised to power 4. So this is the same thing as log 5 625 minus 1. If we bring it up, so we can replace 625 by 5 raised to power 4. We now have log to base 5 raised to power 4 raised to power minus 1. So from here, you open bracket, you have log 4 times minus 1 will give us minus 4 to base 5. From here, we can simplify. This coming to this side will give us minus 4 log 5 to base 5. So it is equal to 1. Minus 4 times 1 will give us minus 4. So the simplification is equals to minus 4. So the second one, have any question before we go to the second one? So consider log. If we are given log 0.25 to base 4. I hope you are following. Log 25 to base 4. So in this case, convert this to fraction. We know that 0.25 is the same thing as 25 divided by 100 because of the 2012, which is 25 divided by 100. So simplify the fraction to give us 1 over 4. Is it not 1 over 4? And we know that 1 over 4 is the same thing as 4 raised to power minus 1. So we can replace it here. So we have log 0.25 to base 4 is the same thing as log 4 raised to power minus 1 to base 4. So this coming to this laws of logarithm, which I have given you the third rule I gave you, that log. If here is b, we have a raised to power c. This is the same as c log a to base b. Mind you that if this is b, for example, we obtain c. Is it not? Let's say here is b. If here is b, this is equals to c, because log b to base b is equals to 1 times c. So from here we have minus 1 log 4 to base 4. So this gives us minus 1. Do you have any question? So this is how you can simplify, evaluate a given logarithm function in any base. Let's do one more. Example 3. You have log 0.001 to base 10. So looking at this, the best thing is to do what? To convert it into a fraction. Have 0.001 is equal to 1, 2, 3. So it will be 1 divided by 1000. So this is equals to 1 divided by 10 raised to power what? 3. Try to put it in index or standard form. So this is the same thing as what? 10 raised to power minus 3. So 0.001 is equals to 10 raised to power minus 3. So put it here. We have log 0.001 to base 10 is equals to log 10 raised to power minus 3, and then apply this rule. This is equals to 3 minus 3 log 10 to base 10. So this gives us minus 3. So this will give us minus 3. Do this once. The first one is log 1 over 512 to base 8 The second is log 1 to base half. Log to base half. Have any question? So let's continue. And now clean this side. A common logarithm is a logarithm with base 10 . A common logarithm a common logarithm is a logarithm with base 10. It is denoted by log to base 10, or I hope you are seeing it. I can now clean this one. Cannot clean here. Alright, a common logarithm is a logarithm with base 10. It is denoted by log to base 10, or simply by log. So this is how you can represent a common logarithm. It is always in base 10 or simply log. So we also have a natural logarithm, logarithm is a logarithm with base e. Natural logarithm is a logarithm with base e. It can be denoted by log e. This is log e. Yeah, this is. I hope you are seeing this thing. That is usually denoted by len. Ln. So let's see how it looks like. A common logarithm is always in this form, or in this form, always in base 10. or you can be written as just log. A natural logarithm is a logarithm with a base e, always in this form. So we have common logarithm. So log s to base 10 is the same as log x. We also have natural logarithm log s to base e is equals to ln ln s log s to base e is equals to ln x. So we can evaluate the logarithm using a calculator. Round your answer to 3 decimal places. So having known how to write a common logarithm and natural logarithm, let's proceed to other things we have today. So evaluation. Do you have any question? If you don't have any question, we'll proceed. Evaluate the logarithm using a calculator. Evaluate the logarithm using a calculator. Run your answer to 3 decimal places. Run your answer to 3 decimal places. So the first one is log 2 over 7. So how do you find this? Log 2 over 7. Use calculator, find the value of the fraction 2 over 7. Then find the logarithm from your calculator. Touch 2 over 7. 2 divided by 7. Whatever you got, you save it. Then find the logarithm, log of the answer you got. You will see that it's approximately negative 0.5441. So the same applicable to ln what? 12. If you use your calculator, because you are told to use calculator, you'll be having 2.4849. So these are how you can use calculator to find the value of the log. You know that this is log to base 10, and we have illustrated a common logarithm. It's the same as log 2 over 7. We don't put 10 here. We know that it's log 10. Log 2 over 7 to base 10. We also know that this one is a natural logarithm of 12. That is ln 12. So the next is using inverse properties. Using inverse properties. How do we use inverse properties to define the values of a given function? So if we are given f of x equals to b raised to power x. So how do you solve this to get the inverse? Its inverse is what? G of s equals to log x to base b. We have done that before. The inverse of an exponential function The inverse is g of x equals to what? Log s to what? To base b. So this is the inverse of this function. So from here, so bye bye.